Okay, so in this lesson, I'm going to graph both tangent and cotangent. So let's fill in this table first. Remember that your tangent is your y coordinate divided by your x. So here is the angle 0, that point there. If this circle had a radius of 1, r was 1, then the x would be 1, the y would be 0. This point up here, the x would be 0, the y would be 1. This point over here, x would be minus 1, y would be 0. And over here, x would be 0 and y would be negative 1. So that's for the angle pi by 2. Here the angle is pi. Here the angle is 3 pi by 2. Now for the 45, the angles in between, this one, pi by 4, we're going to use this triangle that's not got a radius of 1. We're going to say the x is 1, the y is 1. That radius would be the square root of 2. Here your x would be negative 1, your y would be 1. That radius would be the square root of 2. Here your y is negative 1, your x is still negative 1. R is root 2, and here the y is negative 1, the x is positive 1, the r is root 2. So let's fill those in then. So for negative pi over 2, well, negative pi over 2 is going down there, so it's going to be the same as for 3 pi over 2 coterminal, and my tangent would be the y divided by the x, so that's negative 1 divided by 0, so that's undefined. For negative pi over 4, that's this angle here. My y is negative 1, the x is positive 1. That's negative 1. At 0, this line here, my y is 0, my x is 1, so 0 divided by 1 is 0. Pi by 4, that's this angle here. I've got 1 divided by 1, which is 1. At pi by 2, I've got 1 divided by 0. So that again is going to be undefined. 3 pi by 4, this angle here. 1 divided by negative 1 gives you negative 1. At pi, 0 divided by negative 1 is 0. 5 pi by 4, this angle here. Your y is negative 1 and your x is negative 1, and negative 1 divided by negative 1 gives you positive 1. 3 pi by 2, so we're down here. We've already done that one. Negative 1 divided by 0 is undefined. 7 pi by 4, that's all the way around there. That's the same as negative pi by 4. That's the same. That's going to give us negative 1. And 2 pi is going to be the same as your angle 0. So the tangent is going to be 0. Okay, that was the tangents. Now let's do the cotangents. So to do cotangent, I have to do x divided by y. So well, this was negative 1 divided by 0. This one would be 0 divided by negative 1, which is 0. Well, that was negative 1 divided by 1. This one is 1 divided by negative 1, which is still negative 1. This one would be 1 divided by 0, which is undefined. This is 1 divided by 1, which is 1. Well, this was 1 divided by 0, gave me undefined, so this one's going to be 0 divided by 1. The reciprocal of undefined is actually 0. This is going to be negative 1, this is going to be undefined, this is going to be 1, this is going to be 0, this is going to be negative 1, and this will be undefined. Okay, so now we've got all those values, let's have a go at graphing them. Tangent of 0 was 0, tangent of pi over 4 was 1, tangent of pi over 2 was undefined, tangent of 3 pi by 4 was negative 1, and tangent of pi was 0. Now, why have I only done that? Let's go back and have a look at this table. Look what you notice. Undefined, negative 1, 0, 1, undefined. -1, 0, 1, undefined, -1, 0. It's actually repeating, that's one cycle, and then the whole thing repeats again. So the period before it starts to repeat, it's the same for this. This goes from undefined to undefined, undefined 1, 0, -1, undefined 1, 0, -1, undefined. For both of them, they repeat, the pattern repeats every pi. So for both the tangent and cotangent, your period equals pi for the parent function. For sine and cosine, it was 2 pi before it repeated. But you're going to find that for a tangent, it repeats every pi. So let's graph one of these. When your angle is 0, I want my function to be 0. When my angle is pi by 4, my function is 1. When my angle is pi by 2, it's undefined. So I'm going to get a vertical asymptote at x equals pi by 2. Then at the next step, I'm at -1. And the next step, I'm back to 0 again. So this is one cycle of a tangent. It started there, that's one period. And then it would repeat. This would go up here, there'd be a vertical asymptote again. This would be down here, up here. That is what the tangent function looks like. You could go backwards. It's probably best if you actually see this graph, the graph being built. Let me show you this. So what we're going to look at here is we're going to look at the graph of tangent. As we go around, at the moment that's at 0. As we go around, that's it reaching pi by 4, pi by 2, to pi. And then you go around to 5 pi by 4, 3 pi by 2, 7 pi by 4, and to 2 pi. And oops, if you keep on going backwards and forwards over that, you'll see that you've got that same pattern repeating twice. Okay. So tangents will keep on doing this forever and ever and ever. You have a period of pi, there's a gap between these of 1 whole pi. It goes middle, high, asymptote, low, middle. That's one cycle. It goes middle, high, asymptote, low, middle. And it repeats. Middle, high, asymptote, low, middle. And the graph looks like this, going on and on forever. It starts at x equals 0 on the midline. The period repeats every pi, and we can again break it into 4 steps. So we're going to break it into, you can call them quads if you want, but most people call them steps. We get that period and we divide it into 4 steps. And the pattern, it starts at 0, it starts on the midline, then it goes to your high points. These are like your highs. Then you take a step to an asymptote. Then you take a step and you're at the low line. And then you take a step and you're back at the midpoint again. That is the pattern you're going to be graphing repeatedly for a tangent. Let's have a look at the cotangent. The cotangent of 0 was undefined. The cotangent of pi by 4 was 1. Cotangent of pi by 2 was 0. Cotangent of 3 pi by 4 was -1. Cotangent of pi was undefined. We graph that. It starts off with an asymptote. I'm going to circle that just on its midline. The distance between this is going to be, it's not the maximum point on the graph, but it's the equivalent of where we put the high and the low lines when we were graphing sine. This one goes high, middle, low, then has an asymptote. And the graph actually looks like this. And then that just repeats. From an asymptote, you go high, middle, low, asymptote. These are always sloping. If you can see, there's like a slope going like that, a diagonal going down from those 3 points. When you go to the other side of the x-axis, that doesn't change. It's still going to be going like that. So that's your cotangent graph. Cotangent starts with an asymptote, then it's a high, middle line, low line, asymptote. Okay? That is your pattern for a cotangent. For one cycle that repeats, and again, it repeats every pi. The period is pi, so as you step, we can divide the wave into 4 steps, 4 quadrants. The steps are pi by 4. Okay? And it starts at x equals 0 with an asymptote. The function is undefined. It starts with an asymptote. Right, let's have a go at graphing some. So we're going to do this just how we did sine and cosine. The first thing we're going to do is we're going to look for the midline. And it's not really the amplitude, but the vertical stretch is going to tell us where the high line and the low line are. So the midline is going to come from this value here. The whole graph is going to be shifted up 1. And this one's got a vertical stretch of 2. That means your high line is going to be at the midline plus that 2, and your low is going to be at that midline going down by 2. So our high line is going to be at 3, and our low line is going to be 2 beneath that, at -1. Where do we start? This one, there's no value being added or subtracted inside. This +1 this was a vertical shift, not a horizontal shift. It was a vertical shift that took the whole graph up 1. There's nothing going to move it left or right. So we're going to start at x equals 0. The period for a tangent is normally pi, but this is going to be compressed by 1/4, divided by 1/4, which is actually going to give us 4 pi. So our step, or if you want to call them quads, you may, but it's only at this school that you'll ever see anyone call it that, is going to be that period divided into 4 steps. So that will be pi. And the pattern we're going to graph, the pattern for tangent. Do you remember what it was? I don't. It's been a year since I did it. The pattern from tangent is, let me see. Tangent, we're going to go middle, high, asymptote, low, middle. Pattern is middle, high, asymptote, low, middle. Okay. So we start on the midline at x is 0. Then we take a step, and our step is going to be pi. So I'll just label it like that. 1 step, 2 steps, 3 steps, 4 steps. I'll do 1 cycle going forwards and 4 steps going backwards. Okay, so the pattern goes midline, take a step to pi, go to the high line, take a step to 2 pi, and I have to draw an asymptote. So there's going to be an asymptote at x equals 2 pi. So I've done the middle, taken a step, done the high, taken a step, take a step to the asymptote, take another step from the asymptote, and now I'm going to be at the low, take another step, and I'm at the middle. So that is the first part of a tangent. It started here. And if I keep on going backwards, I take a step, and the next point is obviously going to be down. Then I'm going to need an asymptote here. And I take another step going backwards, and I'll be up at the high, high, middle. The next point step would be a low, but I'm only doing 2 periods here. 1 going backwards, 1 going forwards. Okay, so that's 2 periods of that tangent with the start point marked. Let's have a try another one. You have a go at graphing this. Pause your video. On this one, I hope you realise you had to factor out that 3. What we're actually going to graph is y equals the cotangent of 3 times x. I've got to factor that 3 out. Okay. You have to factor out horizontal compression when you start, will be wrong. We're going to graph y equals cotangent of 3 times x minus pi by 3. So our start is going to be, that's going to take the whole graph right by pi by 3. So we're going to start at x equals positive pi by 3. The period is going to be compressed by 3. So the period for the tangent, what you do is you do pi divided by b. Instead of 2 pi divided by b, like we did for sine and cosine. For cotangent and tangent, the period function's only got a period of pi. So it's only pi that you're compressing by b, not 2 pi. So this is going to be pi divided by 3. And I have to divide that into 4 steps. So I want 1/4 of that period. 1/4 of pi by 3 gives me pi by 12. And just as for graphing sine and cosine, it makes it so much easier to graph if your start and your step have got a common denominator. So I can't turn 12ths into thirds, but I can say that 1/3 is the same thing as 4 pi over 12. I've multiplied that by 4 over 4 to get 4 pi over 12. So when I'm graphing, I'm going to start at 4 pi over 12. Let's say that's here. Oh no, my step's only going to be pi by 12. Let's actually count out pi by 12s. 1, 2 pi by 12, 3 pi by 12, 4 pi by 12. 5 pi by 12, 6 pi, I'll label that one, 6 pi by 12, 7 pi by 12, 8 pi by 12. You do not have to reduce those if you don't want to. So I'm going to start on the pattern for cotangent. Oh, let me think. There's a way to remember the pattern for cotangent. I see that 0 and I imagine a line going through it. That reminds me that cotangent, the pattern starts with an asymptote. It goes asymptote, high, middle, low, asymptote. Did I remember that correctly? Let's go check. It's been a year since I graphed any of these. Asymptote, high, middle, low, asymptote. Yeah. So that's how I remember it, seriously. I picture an asymptote going through the zero. Okay, so we have to work out where those high, middle, and low points are. Well, how far was it shifted? It wasn't shifted at all. How much was it stretched? Not at all. Our amplitude is just going to be 1, and our midline is just going to be on the x-axis. That's our midline, and we're just going to go up 1 to get the high, and down 1 to get the low. That's where all my high points are going to lie. This is where all my low points are going to lie. So let's graph one cycle going forward. I'm going to start at pi by 3, which is the same thing as 4 pi by 12. And I start with an asymptote. Okay, right. So at 4 pi by 12, I need a vertical asymptote. Whenever you have a vertical asymptote, x equals, yeah, why don't we reduce that? 4 pi by 12 is the same thing as pi by 3. Then we take a step, and our step is just 1/12. So from 4 pi by 12, I'll go to 5 pi by 12. That's this line here. I've done the asymptote, I now will be on the high line. So that's that one. I take another step, and I have to be on the midline. Then I take another step, and I'm on the low line. Then I take another step, and I have an asymptote. Label that asymptote. This one I will reduce. A pi by 12 is the same thing as 2 pi by 3. Okay, so there is my first cycle. I have to indicate my start was here. I'm just going to circle that point. It was on the asymptote. It's not really a point on the graph, but that will do as my start. It's telling me where I started. And let's go backwards a cycle. So to go backwards the cycle, I'm starting with an asymptote, and I'm going through my pattern that way. I'm going to go asymptote, take a step to a low, take a step to the middle, take a step to the high, and then take another step to an asymptote. So that's one cycle going backwards through the pattern. Okay, 2 cycles of the wave. Try this one. Pause your video and let's start. So first of all, I'm going to want my midline, my high, and my low. Yeah, adding nothing. Your midline is simply going to be at y equals 0. Your A value, like your amplitude, is 2. So your highs are going to be 2 above that, and your lows are going to be 2 below the midline. That's it. 2, go 2 down. Okay, the start. This is going to shift it right by pi by 2. So we're going to start at x equals pi by 2. The period is going to be the parent function divided by b. And look, your value of b is just 1. We've just got 1 times that. So it's just going to be pi. So each step, I hate the word quad. Each step, that's a unique Tompkins thing. You won't see that in any textbook. The step is going to be pi by 4. Right, so I'm going to give these two the same denominator. I'm going to rewrite pi over 2, 1/2, as 2/4. Okay, so let's graph this. Let's mark everything off in fourths, pi by 4. 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, and my score. Pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4. Can't even really see what I'm writing, can you? 6 pi by 4, 7 pi by 4, 8 pi by 4. I probably don't need all of these. And I could do the same steps going backwards. This would be negative 2 pi by 4. Negative 3, that would be negative 4 pi by 4, otherwise known as negative pi. Right, let's just graph it. To do a tangent, the pattern for tangent, it didn't start with an asymptote. This is the one that goes middle, high, asymptote, low, middle. So we're going to start on the midline at 2 pi by 4. 2 pi by 4, the midline is the x-axis. Then I'm going to take a step, and each step is just 1/4. So that'll take me to 3 pi by 4, go up to your high line. Take a step to your next mark and put your asymptote in. That's at x equals 4 pi by 4, which is the same as x equals pi. Then take a step to 5 pi by 4, and you should be on the low. Then take another step and be at the middle. So there is one period of a tangent starting here. And let's go backwards. So to go backwards, I start on that middle point, and I take a step and I go low, and I take a step and do an asymptote. So I've got an asymptote at x equals 0. Then I take a step and go to the high, and take a step and go to the middle. Okay, and your graph would keep on doing that. From this one, it would go to the low, then this would be an asymptote. Take a step, you'd be at the high. Take a step, you'd be at the middle. Take a step, you'd be at the low. Take a step, you'd be at the asymptote. You could keep on drawing these, going on and on and on forever. Oops, I missed it. But you'll notice that all of these lines are sloping in the same direction. Okay, they've all got sort of a slope looking like that. It doesn't ever go sort of sloping this way on one side and sloping that way on the other. That would be wrong. Let's try another example. Are you ready to do your homework? You just go and do your homework. If you want to do some more examples, stick with me. Oh, maybe you should stick with me on this one because it's horrible. Okay, so if you don't forget, you're going to have to factor out that pi. Factor it out. Otherwise, your start will be wrong. Okay, have a go at graphing that. Pause your video and graph that. The graph has been moved up 1, so your midline is going to be up 1. Your amplitude is 1, and there's a negative. So the negative is going to flip your pattern. The pattern for a cotangent normally starts with an asymptote and goes high, middle, low, asymptote. If you have a negative cotangent, remember all that does is it turns your highs into lows and your lows into highs. Okay? It's still going to start with an asymptote though. And that's what that negative would do, that was up here. So our high line is going to be our midline, which was at 1, plus that value of A. So that's going to be at 2. And our low line is going to be at the midline, which was 1. Subtract the value of A. So that's going to be at 0. So this is going to be our low. And our high is going to be at 2. Okay, our start, it's going to be shifted to the right 1. We're going to start at x equals 1. That's a bit of a clue that the values on the x-axis aren't going to have pi in them. They're just going to be numbers like 1, 2, 3, 4, 5, 6. So this one's going to be a lot easier to graph. Our period comes from pi divided by b. And what do I mean by b? B is this factor here that we're compressing the whole period by. So our period is going to be pi divided by pi, which is simply 1. Okay? And our quad, yuck. Our step, we divide that period into 4 pieces. So it's going to be 1/4. So basically on our axis, it's going to be lovely. It's going to be easy to draw. We're just going to have numbers. This is 0. This is going to be 1/4, 2/4, 3/4, 4/4. That's a half, 3/4. This is 4/4 or a whole. That'd be 5/4, 6/4, 7/4. 8/4, otherwise known as 2, and we could take the same size steps going backwards. 4 of them would take me to -4/4, -1. Okay, so let's graph this. We have to start with an vertical asymptote at x equals 1. Don't forget, x equals 1 is the same thing as 4/4. So go to 4/4 and draw an asymptote through it. Label that. That's happening at x equals 4/4, x equals 1. Take a step. Our step is 1/4 and draw a low. Go to the low. Okay, so our low is here. Take another step, go to the mid. Take another step, go to the high. Take another step, go to the asymptote. So that asymptote is at 8 pi by 4, not 8 pi by 4, just 8/4, which is the number 2. So here is my first cycle, and that looks a bit like a tangent sloping that way. But we started at, circle your starting point, we started there, we started on this asymptote. And we could go backwards from the asymptote, going backwards, so we're there at the moment. Take a step and draw a high. Take a step, go to your midline. Take a step, go to your low line. Take a step, draw an asymptote. So that one's at x equals 0. And then just draw your curves in. Okay, that's 2 cycles of that cotangent. Got any more examples? We have got those. We could do one of those, or you could just get on with your homework. Okay? If you want to do these ones, you may, but you can just go and do your homework now if you want to. Okay, let me just graph these if you want to. So first of all, I'm going to go down to. It's got an amplitude of 2, so the high will be 2 above that, and the low will be 2 below that. So this is happening at -4. This was at -2. I'm going to start at -pi by 3. The period should be pi, but it's being compressed by 2. Pi divided by b, not 2 pi divided by b. So my step length for the quadrant is going to be 1/4 of that. So that's pi divided by 8. Oh, good grief. I wish I wasn't doing this one. Why is it nasty? Your start and your step, you want to have a common denominator. And the common denominator you're going to get from 3 and 8 is 24. Yuck. Oh, that top one should be negative. Didn't leave room for negative. So To get to that, I've multiplied this one by 8 over 8. So I've got minus 8 pi over 24. And this one I've multiplied by 3 over 3. 3 times 8 gave me the 24, so the numerator is 3 pi. So let's think about the pattern. I'm going to move all this stuff out of the way. I probably need that workspace. Come on, just move. Oh, okay. Let's use this workspace. Let's think about the pattern. Our pattern for a tangent goes middle, high, asymptote, low, middle. That's for a positive tangent. I'm starting at negative 8 pi by 24, and my step is 3 pi by 24. So the next value here would be at negative 5 pi by 24. Add 3 onto that, 3 pi by 24, I'd be at negative 2 pi by 24. Add 3 pi by 24 onto that, and I'd be at positive pi by 24. Add 3 to that, and I'll be at 4 pi by 24. So I'm going to have to put that on the axes. So first we'll work out where your axis will go. Where does it switch from being negative to positive? Okay, the y-axis is going to go in there. That's where our y-axis is. And it's a little bit, this point is 2 spaces that way. This is just 1 that way. So let's draw something here and a little bit closer for that one. I have another point there. I'm only going to have room to draw one of these, I think. So this one's at negative 2 pi by 24. I've just put this label on. Oh, and that's going to be an asymptote. Okay? Then I'm going to have another 2 points behind that. 1, 2. I'm just going to do one cycle this way. So I start on the midline at minus 8 pi by 24, which is this one here. So I start at the midline, I take a step, and I go to the high. That's that one. So if I label that point, this point here would be negative 5 pi by 24. Then I take a step and I'm on an asymptote. Asymptotes always have to be labeled. This asymptote here is at x equals negative 2 pi by 24. Why not reduce that? That reduces to negative pi by 12. This is at x equals negative pi by 12. Then I take a step and I'm on the low line. My step was here. This is at pi by 24. I'm on the low. And I take another step and I'm at 4 pi by 24. I'm sorry, my writing doesn't really show on this. I'm writing too small. And I'm on the midline. So I've got my points. This was my first one. Circle it and graph in. And I've only put, we'll just graph all over my work. Just one cycle of that tangent. And that was a horrible one to do. That was absolutely fine. Okay, that'll do.